Hello, dear students. Welcome back to another lesson. In this lesson, we're going to continue on chapter 4. Previously, we solved a few examples in section 4.1. Today, we begin with these two examples here. The question says, for each of the two given functions, find the value of the derivative at every local extremum. Before we do that, you need to know the value of the derivative at local extremum is either undefined or it is 0. There is no any other option. Then let's look at this graph. At the local extremum, which is minimum, since there is a sharp corner, then f prime of 0 is equal to undefined. It has no value, it's undefined. But we know it is minimum and the function is continuous. Here, since it's not sharp corner, f prime pi over 2 is equal to 0. F prime pi over 2 is equal to 0 because it's a maximum. And f prime 3 pi over 2 is equal to 0 as well. F prime 3 pi over 2 is equal to 0. Now we have three exercises. In exercises 1 to 3, find the value of the derivative at the indicated local extremum. So on the graph, since there is a sharp corner, f prime 0 is undefined and the sharp corner is at 0. We always look at the x value. X value could be the critical value. And here, f prime 0 is 0. F prime, this 2 pi is, no, that's not 2 pi. That's between pi and 3 pi over 2. The value of f prime is, that's pi x over 4. It is equal to 0. And here f prime 0 is 0 because it's not sharp corner. Okay. In exercises 4 to 10, find the intervals on which the function is increasing and those on which it is decreasing. This one is very obvious. We find the derivative, 2x, the derivative of x squared minus 6x is 2x minus 6. And then derivative equal to 0, we will get that 2x equal to 3, 2x equal to 6, x equal to 3. This x equal to 3 is the critical value. Then if we look at the graph, we know at 3, there is there is a critical value. Excuse me. This critical value is minimum. This graph is positive quadratic. So the graph is going up. The critical value for such case is directly minimum. If we don't know, let's imagine in the exam you are too nervous to know that, then you can continue. We found the critical value, that's x, f prime x, fx. The critical value is 3. More than 3 is infinity, less than 3 negative infinity. For testing more than 3, choose 4. For testing less than 3, choose 2. Then we're going to plug these two numbers into the derivative. The derivative is 2x minus 6. 2 times 2, 4. Minus 6 is negative. The side is decreasing. 3 is critical value. We don't test 3. More than 3 is 4. 2 times 4, 8. Minus 6, positive. That is increasing. The point that is located between decreasing then increasing is minimum. And f prime 3 is equal to 0 because it's not sharp corner. This one, x power 3, it has two local extremums. Let's solve this one actually. Okay. To find intervals of increasing, decreasing local extremums, we begin with a derivative. F prime x is equal to, this 4 stays the same. Derivative of x power 3 is 3x power 2 minus derivative of 3x is 3. Step 1 is complete. Step 2, I'm trying to find critical values. The critical values occur at derivative equal to 0, equal to 0. Multiply everything by 4 to get rid of this 4. So 3x squared minus 12 equal to 0. 12 to the other side. 3x squared equal to 12. Divide by 3. X squared equal to 4. So finally, x is equal to positive negative 2. Why? Because 2 squared is equal to 4, and negative 2 squared is also equal to 4. Now I have two critical values, 2 and negative 2. Then we make the table, negative 2, 2, f prime x to input, fx to see if it's increasing or decreasing. Now, f prime is here, f prime x is here. Input, negative 2. Negative 2 power 2 is 4 times 3, 12. Divide 4, 3 minus 3, 0. So the value of each of these critical values is 0. So f prime negative 2 is equal to 0. F prime 2 is also 0. Less than negative 2 is negative infinity. More than 2 is infinity. Between them for testing is 0. So here I want to choose negative 3, and here I want to choose positive 3. Put negative 3 here. Negative 3 squared is 9. 9 times 3 is 27. Divide 4 minus 3, it is positive. So this side is increasing. Between them, if we put 0 here, this will be 0 minus 3, that is negative, which is decreasing. And more than 2 is 3. If we input 3, we will get 27 over 4 minus 3, that's positive. The two critical values I have, this is minimum, this one is maximum. So as interval, increasing interval is from negative infinity until negative 2, union with 2, all the brackets are open, 2 until infinity. Decreasing is only from negative 2 until 2. This is the interval of decreasing. If we want to find the extremum values, extremum value means y, critical value means x. We're going to input this negative 2 into the original function. Negative 2 power 3 is negative 8. Negative 8 divided by 4 is negative 2. And then minus 3 times negative 2. This is equal to 4. And if we input 2, 2 power 3 is 8. 8 divided 4 is 2. And then 2 minus 6 is negative 4. So the point negative 2, 4 is maximum. The point 2, negative 4 is minimum. As you see, point negative 2, 4 is here, it's maximum. Point 2, negative 4 is right here, which is minimum. Interval from negative infinity until negative 2 is increasing. From 2 until positive infinity is increasing. When we write intervals of increasing and decreasing, remember we only mention the x values. We don't say increasing is from negative infinity until 4. This mistake is very common, that's wrong. We only need to mention the x values. Negative infinity until negative 2 is increasing. Later, from 2 until infinity is increasing. Remember that, don't do this common mistake. We never mention y values in the intervals of increasing and decreasing. This is a trigonometric equation. Then let's find the local extremums. Fx equal to cosine x over 2 from 0 until 2 pi. Okay, we begin with derivative. F prime x is equal to negative sine, the angle stays the same, then times derivative of inside, 1 over 2. So the derivative is negative 1 over 2 sine x over 2. This is the derivative. Now derivative equal to 0, I'll write negative 1 over 2 sine x over 2 equal to 0. We know sine is going to be 0. This 1 over 2 multiplied by sine will not affect anything. That's outside. But this 2 affects the answer. Sine is equal to 0 at n pi. So this x over 2 should be equal to n pi. And n is taking values like negative 2, negative 1, 0, 1, 2, according to the interval. For this interval from 0 until 2 pi, n is taking these values, 0, 1, and 2. Okay. If I put 0 in place of x, if I put 0 in place of n, I'm going to get x over 2 equal to 0 times pi is 0. If x over 2 is equal to 0, x is equal to 0. That is a critical value. When I put 1 in place of n, x over 2 is equal to pi. So multiply both sides by 2, x is equal to 2 pi. And if I put 2 in place of n, I'm going to have x over 2 equal to 2 pi. Multiply both sides by 2, x is equal to 4 pi. Now, if we look at these values, this one is not in the interval. This is not in the interval of 0 to 2 pi. So this is directly out. 0 is the beginning of the interval. This is not acceptable. This cannot be critical. Critical should be something that we have both sides of it available. Then it will be maximum or minimum. But here this critical is one-sided, and one-sided will not be maximum or minimum. It's just one side. Especially if it's the beginning of the interval, this is not an acceptable critical. 2 pi, similarly, 2 pi is the end of the interval. Again, this cannot be critical. Then the answer to this question is the function f(x) equal to cosine x over 2 in this interval has no critical value. But if we change the interval, there will be critical values. The values we found, if they go like in the middle of the interval, they will be critical values. As you see, the 0, if the interval is, let's say, from negative pi until 2 pi, 0 will be maximum. But since it's from 0 until 2 pi, 0 is not critical, so it's not acceptable as maximum. Similarly, 2 pi, if 3 pi is in the interval, at 2 pi we will have minimum. It will be an acceptable critical value. But since the interval stops right at 2 pi, then 2 pi itself will not be critical. Now let's solve this one. Question 7. Question 7 is 1 over x squared. To find derivative, we can use a quotient rule or we can use the fast way. The fast way is like this. F prime x is equal to, since we have x with power in the denominator, add 1 to the power, x power 3. And this power, which is 2, multiplied by numerator and add a negative. So negative 2 over x power 3 is the derivative. As you see, if we divide a constant by x, the result is never 0. That means we cannot find those criticals that make f prime 0, as f prime is not equal to 0 at all. Then we go to the second case, which is when f prime becomes undefined. f prime becomes undefined if the denominator is equal to 0. This denominator will be equal to 0 if x is equal to 0. Now, since we found this x equal to 0 based on making denominator undefined, then we need to test it in the function itself. F of 0 is equal to 1 over 0 power 2, which is undefined. So x equal to 0 makes f prime undefined and makes f undefined as well. That means at x equal to 0, we have vertical asymptote. So at x equal to 0, there is a vertical asymptote. Vertical asymptote is not critical value, but we still use it in the table to test whether the function is increasing or decreasing. That's x, that's f prime, and then f. The vertical asymptote is 0. So when we do vertical asymptote, we're going to put a vertical line here. More than 0 is infinity, let's say 1. Less than 0 is negative infinity, let's say negative 1. This one and negative 1 are test numbers. If I put negative 1 here, I will have negative 2 over negative 1, because negative 1 power 3 is still negative 1. Then negative over negative will be positive. The function on the negative side is increasing, and the function on the positive side, if I put 1 here, this will be negative 2 over 1. That is negative. It's decreasing. And as you know, the graph of 1 over x squared is like this. The side is definitely increasing and the side is decreasing. If we write it as interval from negative infinity until 0, it is decreasing. No, that's increasing. And from 0 until positive infinity, it is decreasing. Now we have this note. If the question said find the value for which the function is maximum, or minimum, we're going to find x. Find the value that makes the function maximum or minimum. This is x value. Find the maximum value of the function is y. Find the critical point. Point consists of x and y. Then we will find the critical value, which is x. Put that value back into fx. Then we will get the y, the x, and the y together will be critical point. This is a Uzari question. Find the critical values of fx equal to x power 3 plus 6x minus 5. You know, to find critical value, step 1 is to find derivative. F prime x is equal to 3x squared plus 6. Now, we can equate this to 0, or we can test these values to see which one makes the derivative 0. That one becomes critical. If we test, because we use the actual way a lot for the examples and exercises, let's use the test way, the satisfying way. Which of these x's will satisfy this derivative to be equal to 0? Now, f prime negative 1 is equal to 3 times negative 1 squared plus 6. That is equal to 9, not 0. So negative 1 is not right. 1. 3 times 1 squared plus 6 is equal to 9 as well. That's not 0. If we use 2, 3 times 2 squared plus 6 is also not equal to 0. Then these numbers that are given, none of them makes the derivative 0. Then this function does not have critical value. Or in the beginning, you can say x squared plus any number is never equal to 0. Always remember that. X squared is always positive, plus a positive number that is never 0. This is why this function has no critical value. So as I said before, we set the numerator to be equal to 0 if the derivative is fraction. The result is the critical value directly. And we set the denominator to be equal to 0 we find the x values that make the derivative undefined. If a value made a derivative undefined, it has two cases. Case one, if the x value is in the domain, or in other words, if f of that value is defined, then that's critical. But if the derivative and the function are both undefined for that value, then that value is vertical asymptote. We still mention it in the table, but the vertical asymptote cannot be critical, cannot be maximum or minimum, because it's a point of discontinuity. Let's solve another question. Again, we try to find intervals of increasing and decreasing. No matter how the function looks, we know step one is derivative, step two, derivative equal to 0, and so on. Now I try to find the derivative. The function is rational, then quotient rule. X plus 1 squared, x plus 1, which is the denominator, multiply by derivative of numerator is 2x, minus x squared stays the same this time, and x plus 1 becomes derivative, which is just 1. Then that is going to be 2x squared plus 2x minus x squared over x plus 1 squared. This simplifies. 2x squared minus x squared is just x squared plus 2x over x plus 1 all squared. What makes this 0? The numerator equal to 0. If we take x as common factor, x plus 2 is remaining, then x equal to 0 and x equal to -2 are the critical values. And for the denominator, x plus 1 squared is equal to 0. What makes inside the bracket 0 is -1. If we put -1 into the function itself, it will be undefined. That means x equal to -1 is vertical asymptote, but we still write it in the table of values to check increasing, decreasing. And here we have 0, -2. This is how the table looks. Then it has two intervals of increasing and two intervals of decreasing. Because the -1 is vertical asymptote, we need to write the interval in this way. -2 until -1 is decreasing, union with -1 until 0. We need to write it as two intervals. Never write these two as one interval because there is a vertical asymptote between them. Don't say interval of decreasing is -2 until 0, as they are both decreasing. No, that's the wrong way. The right way is to separate because there is a vertical asymptote between them. Thank you so much for watching. Inshallah, we will complete the book.